So as you can see, we're going to talk about TV systems, like satellite and cable, because it works the same, like the security. So that's why we put satellite and cable TV. We're not going to talk about satellites, like not to hack satellites. We're going to talk about TV systems. So this is it. Okay. So now. Okay, so a little bit about me. I'm a computer engineer. I'm a security consultant at Trustwave Spider Labs in Latin America, focused on network penetration testing. I'm having fun with security like for 10 years. I've already been a speaker at some cons like Black Hat, DEF CON, TurCon, Source Barcelona, Hack in the Box, Hacks to Hackers Conference, Isha the Sheriff, and others. So just a little bit about me. And okay, so here a little bit why we're gonna talk about TV systems. This is pretty much the three why I thought about this. One, because it's not new, but it's a little bit hard to find things about security, involving security in TV systems. I don't know exactly why, but everything done by the digital video broadcaster standard is not that easy to find, and more hard to find. It's about the encryptions. So everything that you heard, like if you already heard about encryption systems in TV systems, you don't have technical. It's very, very hard to find anything about it published. It's like interesting how it works. So people are not, in the past few years, some encryptions were broken. However, they're doing things like to bypass the encryption. So they're circumventing the security, not breaking. So it's a kind of interesting how it works. And the third thing, it's about people without knowledge hacking. You see, like in the next slide, that people that really doesn't know anything about security or anything related to security or hacking are doing this, and they know how to do this. That's a kind of funny. So this is my uncle's roof. So he has like these 3 dishes, and he has another one, and he put this subtitle, like decodes the signal. You can see because it's in Portuguese, but I asked for the pictures, and he put the subtitles like decodes the signals. So he has like 3 dishes, and here is the satellite names, and he has this dissect that came together just in one cable, so he can control all the dishes from one receiver. So that's why I thought that so interesting. We have a little bit about our agenda. I will make some, like a little overview about satellite and cable systems. We're talking about security, we're talking about outing, and we're talking about some countermeasures that's the companies that made the encryption systems are doing to not to make it unbreakable, but to make it harder to do the things, because what you want when you're doing like decryption, when you're trying to decrypt some image, the only thing that you want is the image. It's the only thing that you want. So if this image is disrupted or something like that, so it doesn't make sense. In some conclusions, one thing that I forgot to mention here, why, it's when you think about TV or satellite systems, you always think about entertainment channels, right? You want to see Fox, you want to see MSNBC, you want to see a lot of stuff. But I don't know here in US, but in Brazil, a lot of colleges are teaching using satellites. So you can use this talk for this too, not for entertainment channels. And worse than that are companies that are doing a conference meetings over satellites. So their security are based on obscurity because you don't know where is the satellite, what satellite they are doing, but probably they're not using encryption at all. If they are using, know that you can use, because I'm not gonna here explain how to crack stuff. I'm gonna make an overview about their security and how they're bypassing. However, you can apply it in it's some for future work. You can apply it for some conference and meetings over satellite. So, okay, so we have a little bit about the satellite systems. Earlier, they were utilizing C-band radio from 3.7 gigahertz to 6.4. And now a Q-band. So if you have your DirecTV, you are using Ku band from this on this frequency, 11.7 and 14.5. And the main components are the programming source. So the people that are actually doing the program, like the Fox, the MSNBC. So then you have the broadcast center. That's the DirecTV itself. So the channels, like the programming source, provide the image. So this broadcast center will make all the stuff for broadcast the image, and also encrypt, like we're gonna see. And then we have the satellites that receive these images, and then after we have the dish that you, as user, receive the image, and also the receiver that will decrypt, and we will know how. So it's basically like that. So, and we have cable system. Here it's the most common way to get TV, like in US it's the most common. Different from Brazil that we have different, like it's not every city that you can get a cable television, and so probably the most of people use satellites, but here you use people use more cable system. Well, the radio signal traveling through the cable using 6.6% the speed of light. So they use this. It's just to make sense, but of course, inside the cable they don't have any interference, so they can use all frequencies they want. So that's because they have more channels allocated in a cable than in the air, because they don't have interference. That makes sense, right? So of course, okay, here the bandwidth increase, so provides also allocated more channels. So it's just a little bit about the satellite and cable system, because here for us it doesn't make a difference, because as I said before, the channels, how it works for satellites and works for cable systems. So how to scramble the image and everything, that's we're gonna see. It works for both. So here we have the conditional access system. That's basic the encryption. It's all based in a digital video broadcast standard, and as you can see by the name, it's where it's a condition. So it's where the provider will decide if the subscriber can have this image or not. So that's why the name is conditional access system. So if you have condition to access, you'll be allowed to. If you're not, you'll be denied. So as I said, the TV broadcast is scrambled the image utilizing the commercial encryption. So as you can see in the bottom, I put like DirecTV and Sky. Sky is like DirecTV in Brazil. It's pretty much the same. They use the video guard by NDS, and Dish Network, NetVirtua, use Niagara Vision 2 and 3 that both cracked. We're gonna see some ways to get the TV using card sharing, sharing the keys, and this one is that I could research about, is the only two that are broken. So if you just have if you have the keys, you can just watch the TV as like you don't need anything else. And as I said, we have a lot of several common scrambling algorithms. Inside the digital video broadcast standard, we call the algorithm like common scrambling algorithm. So we have several CSA available for the TV. So we have several vendors that sell this kind of solution. for the TV industry, and that's it. And as I said, all based on DVB standard, and that's what we're gonna see here. So basically we have this. We have some clear signal, and the keys get into the signal, and you got all scrambled, and you got scrambled. Who here has some cable television here in US? You have TV. Okay, when you were, I don't know if you have a full packet, but when you have a packet, it's like something cool, because I have like Virtua in Brazil, and when you have a channel, when you try to access a channel that you don't have, you can see a little bit of the channel in the scrambled image. Can you see here? I don't know if you can see here, or it's just a blue screen. It's just a blue screen or some screen that. Okay, so in Brazil we have like Net Virtua, and when you can see, it's funny because you can see the image scrambled. So it's where the name came from. So you really can see the image scrambled. So here we have like, this is basically right. So, and after that, we have the scrambling, and you have the clear signal again. So, okay. And finally, we get inside when you're receiving the image. This is the transmission. So you have several process IDs, and you have services, and you have inside the services you have in this case you have the audio, video, ECM. I put that data because sometimes you receive data from the satellite that should be included in the channel, and it's not scrambled or encrypted at all. So this is basically what you can see inside the transmission. So you have the transport stream, you have the PIDs for audio, video, data for any channel. So any channel that you receive a different PID. So here we have channel service 1, that is basically the channel. But you can see it could be another thing too. And you have several until all the channels, right? So I made a lab. I couldn't get like all things that I needed to do a really demo for you, because I bought from China and I'm still waiting. So I did a little lab, and this is, wow, this is bad, right? You can't see anything there, right? No, you can. Oh, how can I do that? Okay, I'm not gonna waste time just trying to make the image look better, but I know, but it's very bad. Okay, well, I will have more maze during the presentation, so just if you can see, I will try to show. But here we have the Portuguese. Oh, you can't see, right? Okay, but we have here, oh no, it's very bad. But the image got... Okay, I think it's a little bit better, right? I just want to show you. No. Okay, a lot of better. Thank you. So as you can see, the PID is responsible for the subtitles as well. So you don't have this problem here because all you listening is in English, right? But there we have like Portuguese. So this is a satellite from Sky that I reached and just mapped all the channels just to show you. So we have here the PIDs we will show you before. Here the satellite that I'm using. And there, as you can see, we have the PID from Portuguese and English. And also, I don't know, I think you can read here, but here, all the programming, all the programming guide is decrypted. So here I have all the information from what is going on in the channel, even if the channel is encrypted. Here I don't have all because it takes a lot of time to update this, so it doesn't make sense just waiting for. So this is just to illustrate what I was saying, right? So as you can see, I know you can't see. No, okay. As you can see here, I put some special packet called ECM, Entitlement Control Messages. So here is everything that we're gonna talk about. So inside the ECM, okay. So inside ECM can be different based on what the vendor specified. However, the structure is also defined by DVB, and of course the contents of the message can vary due to the condition access systems that we just talked. That is the encryption vendor. So we have two control words. So when you think about the like decrypting something, you think like something is static, like some one key. But you can think if somebody has one key, he can decrypt the image and it's all done. You don't need everything else. So these keys are generated handily, and all in one packet that came to descramble image for like 10 seconds, they already have the next key. So they have the two control words, we have the time and date information, and we have the channel identification, depending on the condition access system that you are using. So again, so this is the main packets. So you have the channel, you have the audio, you have the video, and you have this packet that's called ECM, and you have two control words. This control words is the most interesting thing in the encryption because it's the keys. So inside the ECM, you have two control words, one for now and one for the next 100 milliseconds. So you have these control words, you have the timing information, some channel identification. The next one is the control word. So as I said, the control word change regularly. And of course they have to change, because if it was static, the data is not static, so the control word is not static. And if you have the keys, you could decrypt all the time just using one key, right? So inside the control word, you're gonna see how the packet is done and how is its structure, and you can see that we have that they call other even. That's the two control words that are inside the packets. So we have the other even control word that will be used, and we got what the inside the control word packet. You have also what control word will be used now and what control word will be used next. And I think it's the most important. And also the PID, of course, you have all the information, but also the PID is. And as I said, this is used because you can imagine if you don't have some synchronism between the keys, you watch your TV and sometimes it stops and sometimes came back, sometimes it stops, sometimes came back, because you have to receive the key, and of course you have some lag between the reception. Everybody that has satellite TVs, you can see all the time that happens. If you, I don't know, with some cloud or some rain, you have some lag between the reception. So it could be disrupt the image as well. Sorry, I thought that I was listening to a ghost. I don't know. So inside the control words, this is the bytes. We have 188 bytes inside the control word, and there's a lot of things, but it's not important. Just for now, it's not important. So we have the PID, we have the scramble control. So this is scramble control. It's where it will place it. What control word inside the control word packet it will be used. So in this case, we have like this. So we have like two control words: control word 1, control word 2, and odd and even. So if you use a control word 2, this first control word, the another is for the next one, and that goes forward. So you have the control word, like if you have one control word used for now, the other is for the next one. So that applies for all. Everything's gonna be like this. If you have a control word, two control words, one is used for now, and another is for the next packet. And this change, like the control words change every 10 seconds, I think so. So it's basically that. Of course, all the vendors can modify that, but always inside the DVB standard. So that's it. So how it works a little bit with some others properties. So we have the multiplexer or some IP streamer. This is everything. So we have the common scrambled algorithm that's the algorithm itself. So it's where it will be scrambled, like it will be encrypted, because the control words are encrypted. So we have here some control word generator that goes to the common scrambling algorithm that will be encrypted, and it goes with the ECM. So the ECM contains the control word already, but encrypted. So you have the clear signal, you have the multiplexer. So the multiplexer or IP streamer, you have inside the multiplexer. I put like in this way because it's easy to imagine the things working and going on. However, this is one thing, right? This is just one thing, and inside that you have like little pieces doing that. So you have the counter word, some place that the counter word is generated, and then goes to the common scramble algorithm. After that, the ECM is packed with the counter word, and then you got the image scrambled. And after that, you got the scrambled image, and it goes, the ECM goes to the smart card that we're gonna see, and the smart card is, you will see that the smart card reader in this case is called, I forgot what it's called. It's common, oh, I forgot, I'll put in the next slide. And this has the algorithm inside, so it's not a common USB reader, a smart card reader. So in this case, they will decrypt for you, and they will provide the control words for the receiver in this case, and then you got the clear signal after all. Common access model. So conditional access model. So after a big part of it, it's done by this conditional access model. It's basically like normally incorporated a slot for the smart card for security, of course, because it incorporates a smart card reader. It's widely used by DBS, like the digital broadcast satellites, and also for the cable systems. I don't know, but in Brazil, I think the just new ones cable system has smart card, right? The old ones no, right? And as I said, each CAM, it's for each encryption system. So basically, everyone that works, like if you have NAGRA, you have a CAN for NAGRA. If you have an NEDS, that's a video guard, you have a CAN for an NEDS. So this is how it looks like. So this one, it's like a hacked one that I think they provide access to NAGRA Vision and other ones. This is for NAGRA Vision, so it's basically a slot for a smart card that has some chip that has all the information necessary to decrypt the ECM and provide the control words. So this is talking about security, I have to talk about this. This is a system implemented only in Brazil for only one channel. So the thing is, they have some channel that it's provided by a satellite, but of course they have a lot of few ones, I don't know, like affiliated from this channel that provide local TV systems. They have the national TV system, but they have local TV system. It just to not, how can I say? So they have this big one and this little one. Like you have the national systems, right? You have the national television system, and they have the local television systems. And the national TV system don't want to compete with the local TV system, right? So they provide the NAGRA Vision provided a solution for this TV. In this case, it's TV Global. That works like this. You have a GPS on your receiver as well. So if you are in a region that you can have a local TV system, they block you. But if you don't have it, and you see because of the GPS, because of the geolocation, if you have it, they will allow you to watch the TV. And as I said there, it's a FTA, so it's a free-to-wear television system. It's not like a paid television system. It's a regular TV. I don't know how it really works here. I don't know if you have there, but. So I found it very interesting. It's provided just it's NAGRA Vision that provided that and just made this solution for this Brazilian specific channel. So Pwning, we have this is, I think, more than important to talk about Pwning because this is already done. It's talk about how the things are done because as I said, a lot of people buy stuff from the internet and do it at home, but they don't have a clue what they're doing. So we have basically two ways for doing that, already. We have cracking, of course. If you have an encryption system, people work it hard or try to work it hard to break it, to crack it. And we have carrier sharing. This is interesting because they don't need. It's just like I don't need to crack this. I will provide internet. I will provide satellite or cable for anybody. I will provide my keys. So. That's what they do. So but they charge. They charge you like a 10% of the a normal subscription, and they sell a lot. If you look at eBay and something like that, you see a lot of Brazil, because there it's I think the country, everybody does that. Like it's very common. So okay, so the cracking is very simple. So people crack it. Basically, they reverse engineer the hardware to get the software and to crack it, because no software is really published or released from the vendors. So of course they enjoy the encryption weakness. It's no doubt it's a better way because you don't need the keys; it's already provided. And as I said before, no technical details are provided, even for the people that they done that, because it's almost impossible to get details about this. Like, you really have to reverse all the stuff and and work on this, because I couldn't search anything about this. And we have carry sharing. So basically, because the cracking turned out being so hard to do, because people has to reverse engineer the hardware, and they have to get from the hardware everything that they need to crack. So forwarding the key became the solution. So they're utilizing our official card. So some guys, they really buy that, and they provide the keys for you. It seems like you'll see later that I put on some slides. That's some big companies do that, and it's really weird. So, as I said, so again, it's shared the control words. So the control words are sent to utilizing internet or satellite. That's another thing that I thought a lot, and I try to research about this. How people are delivering keys utilizing satellites. If it's like, of course it's illegal, like just for delivering the keys is illegal. So, but I don't know about how they're doing that with satellites, if they're paying for that or not. So they do that usually is internet or satellite. So they have a name for that, like IKS and SKS, and they utilize a receiver that it's really like, it's a receiver that they claims to be FTA. So it's a receiver for satellites. Okay, so you can buy a receiver for satellites. And someone has a HD and have high definition and everything. However, they have like, I will show you before, they have like hiding menus inside the receiver where you can configure clients for satellite key system or internet or satellite key sharing. So normally you pay a provider like $5 per month, and they will provide you the keys to decrypt the sign. So that's how it works. So as I said, like internet key sharing, providers utilize a server to share the control words. That's very easy even to make it. As I said, I was expecting receive some hardware that I bought, because as you can see, it's all hard to analyze. It's everything very hard to analyze and to know more, like for yourself doing alone, you know. And of course, it uses the internet. So, and we have the satellite key sharing. So, providers utilize a data frequency on a satellite, like it works like an internet service provider, to provide the keys. And for example, this satellite provides the keys, and it's for free. So if you have some, I don't know, because as you know, you can see satellites that I can see in Brazil. So like you were east, we are west. So in this case, they provide the keys for Amazonasat and Star 1C2. So you can just point your satellite for there. You configure your satellite key sharing in your client. You have a client for that. You configure, hey, this is the satellite that will provide you the keys. And okay, and of course it's more stable because it's just satellite and you don't have any interference for like internet. Like it's low, but you have some, you know. And okay, so this is basically a key share. Okay, so this is a basic some receiver and a dongle. So this dongle can be for internet or can be for satellite. In this case, it's for satellite. So you put this dongle on your receiver, and you can configure as you can see here. So here, configure internet key sharing. So server port, username, password, server IP. I didn't mention that, but I really wanna see how these keys are delivered. So in this case, I didn't. So as you can see, you can just select like IKS, Internet Key Sharing, and then you can configure your server, and then it's done. You receive the keys. And in this case, like as I said, this is from my uncle too. So receiving the keys, utilizing the SKS, and here the satellite that you were receiving the channels, you were modeling the channels. So there you model some transponders that can, a transponder that can provide you the keys. I don't know for sure if it's that one, I don't know. But here's, my uncle took the shots and I don't know. And here, utilizing what satellite I wanted to model the channels and crack it. So about these outing products that you have, it's very easy to find. As I said, some products claim to be just for FTA, but they have some hiding menus. That's, yeah, it's weird, right? And some dongles that they call dongles, and are provided by the same companies as well. So you buy your receiver, and then you can buy your dongle like for satellite or for the internet, and then you can configure and receive the channels. We have here some outing software is also very easy to find, and we have some CAN emulator. I put that like generic smart card readers, but it's not that generic because so you have to be specific. You have to be serial, or there's a special smart card reader. It's called Phoenix that can configure the voltage and everything in the smart card, and it looks like a serial for Windows, for example. So that's why it's a little bit different. And a USB serial DVB receiver you need for doing the test. In this case, I know here. So this is the key emulator. So as I said, you need the script. I don't know. This is for NDS. That's video guard that I have there. So I don't know for sure if it's working already. You see later in the countermeasures that the NAS and video guard implemented the decryption of the ECM that generate the counter words inside the receiver, but I don't know for sure if will work or not, or just it's old stuff. I know for sure that you have for Nagra. That I know for sure that you can have it. That's because it's the most popular. I don't know. There's a lot. When I was trying to, because you can imagine, I have like, you have just one satellite in one position, of course, right? So if you have to change, you have to change it. And I have a problem of 3 meters, and I didn't have a chance to point into another satellite. Okay? So probably next. So this is my lab description. I have a USB DVB receiver. I have 2 dishes pointed to C-band 70 degrees west. That's called star 1C2. That's also provided FTA channels. And I have another channel, and I had another dishes pointed to a Q-band 43.1 west. That's called Intelsat 11. That's a paid television system. Some softwares to map. I utilized Prog DVB, DVB Dream. And as I said, I'm expecting other softwares. So it's like it looks like. So, and here a little bit more. So here you can see a little bit more. You can see the ECM. I didn't mention the EMM because it doesn't make sense right now, but so what more I can show you from here? Okay, the type of the condition access. So here in this case is utilizing Power View. So I think it is. And here, as you can see, so Sky is one, and DirecTV, I think so, provide for you not just entertainment channels, but provide you college education and also meetings. So here I could map all channels available and everything available on this satellite. So as you can see, I have 82 channels for TV, 35 for radio, and 6 others. So as I said, the impact for that is not just for entertainment channels. Access conference meetings over satellites can utilize it too. And I don't know, as I said, I don't know here in US, but in Brazil it's very common education from distance, like not on site, and they utilize satellites to provide their content too. So a little bit about the countermeasure. As I said, in wiki encryption system, the smart card decrypts the ECM that provides the counter words, and the counter words are sent in 10 seconds from the smart card to receiver. This is how it works, like in the week. So, but some vendors are utilizing like Irdeto and NDS, that's video word, implement another layer of decryption. So the counter words decrypted by, that is the encrypted ECM, will be sent encrypted and only decrypted by the receiver. So they have the smart card reader, but it's all including the receiver. Like I think if you can cut a step on this, so they will direct to receiver. And also, if you decrease the interval of sending the counter words, in this case, in the regular case, 10 seconds, you can cause a lag and probably not being good to watch. So it will be bad for people trying to steal the contents of the image. So this is it. So the conclusions, like it's highly proprietary. Everything that you listen about condition access systems is like everything's all closed. If you ask for the vendors about any documentation, they won't provide you. No documentation on encryption systems. So hardware for analysis is very expensive. I try I contacted some companies for like trying to buy, but it's so expensive. And as I pointed out there, not just entertainment channels, because people can think about just entertainment channels, but it's not. And of course, for the future work, I didn't put a slide for that, but for future work, I will try to analyze the data between the keys, how the keys are being delivered, see a little bit more the keys, and about that one, that the receiver decrypts the ECM directly. I will pen test the receiver, so that's what I have for future works. This university I thought is good. It's a book, Smart Card Token Security and Applications, and is monitoring condition access system by Bridge Technologies. So, do you have some questions? Okay, so you have my mail, you have my Twitter, I have my LinkedIn, and please fill the Survey Monkey, just for the guys. and thank you for taking time.